Hey, what's up guys, my name is Cherno. Welcome back to Devlog Monday. It's Thursday. So, for those of you not aware, this is a little series which is essentially just a development log of Hazel, my game engine. I am making a game engine, which is, like I said, I'm not gonna lie, some pretty poor life decisions led to this moment, but I am doing it and I don't know what else to do, so here. No, I'm kidding, jokes aside, I really do like working on this stuff, and I have some pretty exciting stuff to show you today that is mostly thanks to the community. Now, a few months ago, a man by the name of Karim messaged me and said that he had to do an internship as part of his university studies, and he was wondering if he could do it for Hazel with me. And I was like, absolutely. Now, Karim is very interested in graphics, and actually one of the things that he kind of presented me with, which was his project for university and also kind of like as a pitch, was essentially a version of Hazel that he had kind of made into his own game engine, which had a lot more rendering features. He had basically used it like as his final university project. Now, this engine had like deferred rendering, it had like all these various effects like screen space ambient occlusion, a bit of screen space reflections, you know, all of this stuff. So it was a lot more fancy than kind of the rendering features that were available in Hazel at the time. And so Karim joined the Hazel core team for 3 months, and I'm about to show you what he's been working on. He's been primarily working as a kind of rendering engineer. So since Karim joined us as someone working on rendering, he asked me what I wanted him to do. And I mean, there's so many rendering things that I want to do, but I knew that the first thing that we need to really be able to handle is lights. I mean, that makes sense, right? At the moment in Hazel, we've just been using like forward rendering, basic old classic forward rendering, which basically just means that you have a piece of geometry, you render it, and right then and there, you just shade every pixel and you do every lighting calculation. Now, most engines these days use something called deferred rendering. Deferred rendering basically just means that instead of doing that actual lighting calculation right there in 3D space with all of your geometry as you render it for the first time, you basically don't do that. Instead, what you do is during those kind of 3D geometry passes, you just simply gather information about the geometry, such as like, what is it, what materials is it using, where is it in the world, like what are the normals, where is it facing, all of that. You gather that into a bunch of textures, and then you just do your actual shading kind of in screen space on just a quad. That way you don't have to waste time like calculating all this different shading for different things where lights might not be in that specific area, or maybe it's been like overwritten by another piece of geometry. There's a lot of benefits. However, because you are kind of faking this, like I like to call deferred rendering fake rendering, because you're not actually rendering stuff in 3D space. I mean, you are to generate those buffers in the first place with all the data that you need, but at the end of the day, you're just actually doing your shading on a quad. And because that's happening, it introduces a lot of issues. A lot of them do have fixes, but I guess conceptually for me, it's far from ideal. So what I told Karim to do instead was to look into forward plus rendering. So I'm not going to explain forward plus rendering in this video. I mean, you'll see some of it in action, but forward plus rendering is a little bit different. It's basically forward rendering. That's kind of why it's called forward plus. By the way, it has a lot of names like clustered forward shading, tiled forward shading. There's a lot like volume tiled forward shading. There's a lot of different names for it. But essentially what it does is it reduces the amount of pixels that have to process certain lights, thereby optimizing your lights. So essentially what happens is the screen gets divided into tiles, and these tiles are not just kind of like X and Y tiles, but they have depth as well. They're basically these little volumes, kind of like voxels, but we won't get too much into that. And before we do any actual like shading and figuring out what color like these meshes that we're drawing in our scene are, we have this pass where we go through and we work out what tiles are affected by what lights. And so what happens is that data is then used to make it so that we are not processing an excessive amount of lights per pixel. If you still have like 1,000 point lights on top of each other, and they're all kind of affecting the same pixels, then of course you will still be slow. But in a real kind of big 3D world, like a scene, this huge scene, you can literally have like thousands of lights, and it's not really going to affect your performance that much, because for any given kind of group of pixels that you're rendering, you're only dealing with the local lights that are in that specific area. And as I mentioned, this works in 3D space because it like uses these volumes essentially. So what that means is that if something is in front of the camera that's obscuring the vision of other kind of fragments that are in the background, they're not going to they're not going to be doing any lighting calculations. Anyway, this is a lot easier to actually show and kind of demonstrate, you know, visually. So let's jump into Hazel and take a look. So it looks pretty much the same, but now what we can do is we can create a point light. And when we create a point light, I added this icon, by the way, like 30 minutes ago on stream. Twitch.tv/the Cherno, by the way, is my live stream. I stream, like, I don't really have a schedule, but every now and then when I'm working, I'll just throw up a stream. And so this is what I was doing today, basically adding these icons and playing around with a few visualization settings, which you'll see in a minute. So basically we have this point light. We have a few options here, like we can change the color, for example, so I can make it like red. We have an intensity. We have a minimum radius, we have a radius, and the radius is just like basically how big the light is, and we have a fall off, which kind of tweaks the fall off, like the way that it does fall off. It's pretty subtle at the moment. We're still kind of working out what parameters we actually want to have, but this is basically the way that it works for now. So if I kind of reduce this, maybe move this up here, you know, we can start to play around with this. I can duplicate it. I can set the color to something like blue. Now we have like our nice little kind of pink in the middle as the two lights kind of intertwine. Anyway, that's the basic idea. And I mean, like, there's, you know, a lot of stuff you could obviously do with this. You can have a lot of these lights. I mean, at the moment, we've actually limited it to 1,000 per scene, but that's not, like, it doesn't need to be 1,000. It can be, realistically, we could, as long as they're not in the same place, we could probably render like 1 million of these. So it's pretty nice. And obviously if I like drop into this world, and then you can see everything running as usual. The audio is playing, and this is kind of our normal scene. So, you know, in terms of how it works, point lights themselves are pretty simple. But the benefit here, obviously, as I mentioned, is the fact that this is all kind of, you know, these lights are culled according to how much kind of range, I guess, they take up, and also where they are in the world, meaning that like when we actually physically shade these pixels, we don't have to worry about like, oh, there's a light next to it, because if it's not affecting it, then we're not doing the lighting calculations. We don't really care about that. We're culling it kind of before the shader even sees any of this. So I've actually added an option over here. It's a little bit difficult to see, but it's over here. It's called Show Light Complexity. And so if I turn that on, what you'll actually see is this little view. So this shows you the tiles, which is pretty nice to see because you can actually see the tiles. They're 16 by 16 pixel tiles. And what this mode is intended for, basically showing you, is the complexity of your lights for a given pixel that you're actually rendering. So you can see that this kind of area over here is just not lit by any point lights. That's why it's kind of the normal color. But then as we get kind of into a more complex area, basically meaning that there are more lights affecting that pixel, it's kind of like a heat map. It gets closer to red. So if I, let's actually kind of start over. If I delete all these lights, let's add a point light. I'll make it kind of the radius kind of small, so maybe like 3 or so meters. I'll move it over here, and yeah, it looks a bit weird when you look at it this way. Obviously without this, it kind of looks like a normal point light. You can see it's kind of affecting like the cube a little bit, but this shows you what it's really affecting. And then if I duplicate this, right, then you can kind of see where the lights overlap. Now, of course, this is kind of dependent on their radius. The smaller the light, the less it overlaps. That makes sense, right? You'll also see a little bit of overlapping from the underside because, of course, it is a point light. So, like, there's no kind of, like, you know, the pixels, they don't know that there's stuff kind of obstructing them. But, of course, if you were to move this up sufficiently high, then if you look at it on the other underside, you can see I'm only actually seeing that kind of other one. The second one, not the first one. Another good example actually is that if this light over here, we can't click on them yet, which is a little bit annoying. If this light was like behind this sphere over here, for example, then you can see if the sphere is actually in the way, you know, we're not rendering those, that light kind of isn't being rendered. It's not being calculated because there's a sphere obscuring the pixels that are behind the sphere that are lit. So it's pretty clever in that sense. So let's talk about the light complexity. So if I basically have a bunch of these, you can see as I keep duplicating them, we wind up with spots that are slightly more complex. Now at the moment the scale is a bit, I don't know, I just made it up basically. At 16 lights it will be red. So if I just basically keep duplicating it, you can see that eventually we get to red. And red just means that, hey man, you've got a lot of lights in the same place, which basically means you might want to reduce that because it might cause performance issues. You can see it's totally fine running over here, no problem at all. But might be something you think about. I haven't not really done too many performance benchmarks. I know that we can handle like thousands of lights like at 60 FPS, and that's totally fine. But if they're all in the same spot, I'm not sure what that is like really. But yeah, so let's open up something a little bit more interesting just for fun, like sponsor, and then we can try adding a bunch of point lights and seeing how they affect the scene. Okay, so what I've done here is just added a bunch of kind of multicolored lights. Again, if we turn on that light complexity, then you can see what's going on here. They've got like 4-meter ranges, so you can see they're even hitting the torus over here. And then the other thing is you can actually kind of access this light complexity during actual gameplay as well. So if we drop into the world and we take a look at, you know, all these nice, lovely lights, we can turn on that light complexity. And now you can see that, you know, because obviously it's going to be different for the editor when you see like everything from above. It's important to actually visualize what it's like during you know, actual gameplay. And you can see here that we can kind of see what's going on with all of the lights. So yeah, pretty cool. I think this visualization mode is really cool because it lets you actually see how it works, kind of. It helps with actually understanding how forward plus rendering works, but then also it's obviously useful for debugging maybe slow kind of areas in your scene where the cost of kind of calculating those fragments, those pixels, can be a little bit expensive because there's just a lot of lights in the same kind of place. Anyway, I hope you guys enjoyed this video. If you did, please don't forget to hit the like button below. We're getting all of these really cool tools. You know, now we can have point lights. I haven't added spotlights yet, but that's on my list as well. So we're getting all of these tools, and I honestly haven't even had a chance to use this much to actually build scenes. So I'm really excited to be able to do that. And going forward again, hopefully I'll be able to show you guys some more exciting scenes than simply like this sponsor demo. If you have any questions, please leave them in the comment section below. Again, a huge shout out to Karim, of course, because he was the person that did the majority, like 95% of the work to get it into this state. Karim's internship is coming to an end, and unfortunately I can't afford to hire him full time. So he's asked me to mention that if anyone has any work or any leads for him, any kind of job opportunities, then please let him know. I can definitely recommend him. I think he's done some amazing work on Hazel. If you would like to support Hazel's development, you can go to patreon.com/thecherno and you'll receive access to all of this lovely source code. Thank you all for watching. Have a great rest of your day, and I will see you next time. Goodbye.